Hello, welcome to a video on CADS RC Column Designer, part of the CADS Smart Designer Suite. The Smart Designer Suite is made up of a series of programs for concrete and steel design. We're focused on concrete videos at the moment. They are quick to learn, very simple to use. They will design to BS 8110 or EC2. Indeed, you can switch from one code to the other if required. They're independent licenses, so you don't need to buy all 5 of the concrete programs we have. You can buy the Beam Designer and the Pile Cap Designer if that's all you need, and they're cloud-based. So for flexibility of working these days, there's Office and people working at home. The program can be installed everywhere, and provided you have access to the internet, you can get on the program. If they're used standalone, these programs allow you to put in the section sizes and the loads, but there is a link to CADS A3D Max, our frame analysis program, where all that information would be passed automatically. I'll show you in the video. We have comprehensive detailing options where we can in each of the design programs, because we're very conscious of linking into CADS RC to improve your productivity, and that's where the detailing and the scheduling will be done. These licenses are permanent licenses, it's a one-off fee, and they can be rented if required. As I say, it's part of a suite of programs. Column Designer, there's Beam, Pile Cap, Pad and Slab Designers, focusing on Column Designer today. So the program features, it's for rectangular or circular sections, 28110 and EC2 as I've said. The program, given the slenderness ratio, will work out whether the program is defined as short or stocky or slender, and apply the appropriate design checks to EC2 and 8110. Loadings can be axial only, or uniaxial or biaxial, and can be used standalone or linked to CADS A3D Max. The 2 modes the program has are design mode and check mode. So in design mode, it will calculate to a given range of bar types that you want to, bar sizes that you want to design to. It will design a series of arrangements that resist the loads you put in. And in check mode, it does the opposite. For a given bar arrangement, it gives you a range of axial loads and moments. Indeed, it creates a diagram there you can see on the bottom right, the typical interaction diagram, the MN curve. And there's also the bonus of a link to CADS RC for detailing and scheduling. Okay, so let's have a look at the program. We're now in the RC Column Designer. I'm going to go through a couple of our examples, one in Eurocode, one in British code, and I'll show you the difference between the calculation modes, either design or check. So default is Eurocode. Let's have a look at the 8110 code to begin with, and I'll switch to Eurocode. These 2 options, by the way, just vary in the way the concrete type is put in. So the amendment has the cube and the cylinder strength. The 8110 only has the cube strength. We've also got there a detailing code, so that the program will be linked into CADS RC later on. We'll show you that. So these are the default settings for size. This is square, but it can be rectangular, not a problem. And then the other option you've got is design or check mode. So design mode will work out what bar arrangements you need for a given loading, whereas check mode does the reverse. It works out what range of combination of axial load and moments will work for a given cage. It works out the interaction diagram. So we'll do a design mode to start with, and we're looking here at the materials and the design parameters. You've got the strength class, as I just mentioned. That's giving the cube and cylinder strength there that we're going to use. We've also got then the link details here and the main reinforcement, including their size range here. So this is basically the size range you want to design to. So the program will give me a range of bar sets from 40s to 12s with different links. You can also control the longitudinal spacing of your rebar there and the type of steel. You can see the same for the links. So the design parameters are simply the partial factors. They're straight from the code, but you can change them if you want to. Any details on anything you see me putting in that you're not clear of, the program actually has a very comprehensive help facility within it, and it comes out sensitive where you are in the program. So putting in materials comes up with a guidance of how to put materials in. So that's the setup. Then we've got the shape of column size and so on, the classification calculations done there, the loads, the auto design and so on. So column shape, we can choose circular or we can have rectangular, square. Once you've chosen that, we can just put in what the size of the column is going to be. Now you can see it's a 4 meter high clear height column, 400 square. Again, it can be rectangular. You can see here braced or unbraced. Unbraced simply means that the columns are doing all the work horizontally. the program, when it's in the British code, will check the slenderness. Now, obviously, there are different checks for the columns if they're slender or short and stocky. So if we have a brace column, then the program's looking for a slenderness ratio where the limit's 15. Whereas if we change it to unbraced, then that limit drops to 10. So that's one of the significant differences of classifying what type of system you've got there. The other thing is the effective length that it's worked out from this effective height here. So that's worked out either by you putting it in, or you can work it out from first principle. We've got fixed, but we could put partial in, and as you can see then, on either face we've got a value of 3.2 now, because the effective length factor is now 0.8 instead of 0.75. If you want to put in a column that's only fixed at the bottom, you can only do that in the unbraced mode, as you can see there. Look. So we're going to run a very simple example through in fixed mode. Obviously it depends on your geometry as to what you're going to use. You can see the slenderness ratio there is 7.5. The program does warn you if you go there you go. The program does warn you if you go slender. So you can see what checks it's then subsequently going to do. You can see the covers here. They're the other things that we have to put in, obviously, for design. If you put something silly in and you try and run through the program, it will warn you that you're going against what the guidance would be. So here we've got the cover in terms of fire prevention here. This is done as a check subsequent to the design. So it needs to know what the actual sizes of bar are, but the durability classifications are very straightforward here for each face. So we've got a total of 35. So if we put in 35 there, you can see it's okay, and we can apply it and everything's okay. So we've put the column in, we've got the size, we've got the rebar, we can put the loads in. Now these loads, if you were linking to our CADS A3D Max frame analysis program, those loads would indeed come through in that link as with the size of column. You'd only be doing design, but we're using it as a standalone program here, so we just have to put the loads in ourselves, and they can be 1 set, 2 sets, 3 sets. It depends on the job really, but you can see what I've got here on each face and an axial load, and you can carry on, and then the program wants to uses those as an envelope. Then we've got the auto design. So this is really what the program is doing for us in design mode. We've got 40s to 12s and different arrangement of bars at work, and obviously from 16s upwards you're really being slightly inefficient. You probably won't win the job with those sizes, so you're really down here 6 or 4 bars. Go for 4/16s, pretty common, and then more details are given here about what you've chosen on each face in terms of rebar area. There's a check there against the maximum that we've got as a default, and the links. Look, there we are. So that's what you get on screen, but then in the output, and we can choose brief or detailed, we can add all the different headings and tell the program whether we're checking or designing. There are different headings for each mode, so if you hit design mode, it doesn't need that data there. And then we can go for a preview. This can all be sent to Word and Excel, by the way. There are options in the program for that. So we've got page 1, page 2. You can see the covers, materials, design information, design code we're using. These are the moments and loads I put in. You can see the results of each cage that you can use then. That's the one I chose. And then going on from that, we've got page 2 and 3. Now if you want to zoom in, by the way, you just double click on the document. You can also basically tab through it on the screen here too, as you can see, and then as I've done 2 consecutive pages and go backwards and forwards, just so you know how to navigate. There's also a spyglass there too. But you can see that how the design was done here. We've got the moments it's used and the axial load. You can see the enhanced moment there according to the code. So it's taken the maximum applied low moment and added taking into account the eccentricities that the code wants you to use, and there's the utilization ratio. Now what we can do is let's change that to say a circular column, and same height and so on. Let's make this unbraced, and we're going to apply that. There we go. 6 bars minimum, so the loads are the same. There we go, and we're going to run this through the auto design. There you go, 6 12s or 16s, so we'll go for the 12s, and you can see I've basically changed the column, and the column is now a long column. It's a slender column, so the checks are slightly different to what we had before in terms of the moments and so on. And if we go into the output here, you can see the values that it's used. Just go preview. We've already set the calc up. It's just changing the size of the column that we did, and you can see the increased moment there because it's a slender column. Okay, that's pretty straightforward, the British code. The other mode you can work in, by the way, is the check mode. So again, for the cage that we've just designed, it then offers you the choice of which one to use to work out the MN curve, or you can indeed put this in yourselves. So let's say 16s. So this is something you can put in directly, or you can say pick from the design information, and then we run the calculation to work out a range of axial loads and moments that work, and that gives us all these values, which is nice and dandy, but it's nice to see it in a curve, this interaction diagram. So it's a check data, preview, and you can see then, there we go, there's the very typical MN curve, I used to call it, interaction diagram, I suppose it's called now. And it's basically anywhere in there you're able to work with all the loads on your building. Okay, let's now switch to the Eurocode. There we go. A few details I can show you. This is slightly different to what you've just seen. User defined is available, as well as the default values we put in. The Irish annex is there, along with the Eurocode annex, so you can basically tweak it to whichever annex you're in. You've got material, partial factors and so on, materials that we've used. Detailing requirements, you've got there the max and absolute spacing for bars and so on. And then second order effects. So if you've got a slender column now, we go into second order effects. That's the inclination for lack of plumb. That's a moment eccentricity you have to calculate. And this is for saying that if the maximum slenderness for ignoring second order. So you can again change that. This can all be changed. It's just default values. Okay, that's so. The column is the same as we had before. I'm going to switch back to design mode. We would have left it in check mode just now. So these are the loads we've got, and we hit design, and you can see now again we've got that column with the numbers of bars that the Eurocode wants us to use. You can see it's a slender column, biaxial bendings confirmed, bar details again. Not much difference there really. In the output though, the Eurocode really does do a lot more, require a lot more from the engineer than the British code. The slenderness ratio to calculate the limit does require a lot of work, and that's what the program's done for us. So if we go into the print preview, let's go through that. So we're designing. Here's our first page. Let's just go to consecutive so you can see what we've got. So here we've got the effective lengths and so on from the data we put in. That's pretty standard. Covers, materials. You can see the loads and the design codes there, look. So these are the slenderness ratios that we've calculated for this column. And if we go to the page over here, you can see it's come up as slender. And that's because if you take a look at the program, you can see what the value is of the slenderness limit. So our slenderness is way over that. So it's a slender column. That's where you can see the values. You can also see the moments we put in. Now this is where the extra work is done in the Eurocode. All these other moments that are calculated for different eccentricities applied for minimum eccentricity, geometric imperfection for lack of plumb. That's where the 1 and 200 comes in. And then the second order effects are working here because it's a slender column. And then you can eventually see over here what the design moment is, indeed what the capacity is, and then the utilization ratio. You can also see up here coefficients A, B, C. Those are used in the calculation of the slenderness ratio, so those are given as output. Okay, so that's the Eurocode design, and then we've obviously got the we can change that to check mode and run it through, and again you can see the various axial loads and moments that the program can take. Okay, so very similar to what you had before. There's our curve and the axial load and moments that the program has calculated to make up that curve. Right, okay, so that's the program working in standalone mode. So I just want to run you through two ways to link to frame analysis and the column designer. Rather than having to put in all the information that you saw earlier about the column size and the loads, that can all be ported in from a frame analysis. Two methods, one column at a time, or we could do a group and design all the columns in the building in one go. Just show you the individual column process. First, select your column, go into the column designer. This is then opening up the column designer. It's got the size of section from the analysis model, and then we can go into the loads, and you can see all these loads that have been brought in. There we go. So those are all the loads that are coming from 3D Max, and you can see the column properties. It's got the size of section there. We can make a decision about the bracing, and the end fixities have come through, so we don't need to change that. These are the effective heights here. We can apply that and just run the design. There we go. We've got a section size there, and we've got all our bars. That's how you would do it one at a time. To save time, though, you could then run it in batch mode. So let's just put in a suitable orientation. So the job then of the user is to select the columns that you want to design. Let's see if I can do them in one go. There we go. There's all the columns, and we go up here and create a group. So the idea here is really one of time saving. So rather than passing each column through at a time, coming up with some cage arrangement that fits all, or groups where you want them to be the same, I'm going to do them all in one go and make a decision about that later. There's my code that I'm using. You can edit the design parameters if you want to in here, and we just so next and finish. So you'll see the columns that we've put in a group at the top there. Just put it up the top. You can confirm that by picking on the group below, and then this is our group table. Again, if you've seen the other videos we have on general steel and concrete design, you've seen this process before. So we pick on all the columns and we simply do a design. So as I say, bear in mind this is doing some 20-30 columns, I think it is, passing that through the designer. You can see the grade of concrete. Obviously they're all the same. They've all passed to varying degrees. The blue is well in and the green is pass. You can see across here then the types of arrangement it's using: 412s, 1012s, and so on, and links. We've got 8s at 125 nearly everywhere there, if not everywhere. We're up to 96% efficient. One of the worst ones is here. Now typically the corner columns are the worst culprits here, so you can have a look and you can see here the area provided and required here. If you click on 507, it's sure enough a corner column, and if we go say to the list up here, you can see 5F, there's another corner column. So you can see the how this is working. I'd put 12s everywhere, corner columns, 1012s or maybe bigger bar, which you can obviously get from the design program option. So that's how you would do them all in batch. And say to see the details of the column that we've chosen, you just click on details below. It opens the column designer program, and you can go in there and have a look at all the bar options that you saw earlier as a standalone program. Okay, so that's how we can link from analysis through to the column designer. And finally, now we're in CADS RC. We're going to detail the columns that you've just seen in that frame just now. In CADS RC, you'll see the menu where we can go for the detailing options. It's under our macro detailers. Now these can all be used by just typing in the information if you want to, so you don't actually have to bring in data from design in order to be able to detail a column. You can do it just by manually typing in what you want. I'm just saying that all these columns are called column 1 and that I've got 12 on site. So every one I bring in, there'll be 12 multiplied in the schedule. And you can see we can tabulate the results, or we can do a detail if you work that way. You can put the size in, the bar types, and all the arrangement manually, but we've got a design. So all we have to do is go to those files we just created, bring in a column, and say draw. Now that's the name of the file, so we go OK. And you can see the detail we've got there. The remember the 12s for the slightly smaller reinforcement requirements, and we can move that to wherever we want it. And then we get a section, and we can pop that down the bottom. Now let's just go back to the column detailing command, and we'll bring in one of the other, number 4. Yeah, this has got slightly more bars in it. It's one of the corner columns. And again, we can just move that to position over here, and there you can see the extra rebar in section. There we go. So that's the 2 column sizes that we had from the design. They're all detailed up now and labeled. And if we go into our schedule, this is the CADS RC scheduling facility. You can see the bars there, but it's actually nice to see a bar report. So see a full schedule with your headers and everything else. If you've seen one of our CADS RC videos, you'll see the same thing. There we go. So there's all the bars there, look, and you can get weights and so on as well. So that's the link to CADS RC. Okay, so just before I go, CADS concrete design software, you can see the Smart Designer suite with the individual programs in here which link to our frame analysis but can be used on their own. You've just been watching the RC column designer. Again, these all link into CADS RC detailing software as well. There's a new interface we're developing where we're putting all separate little affordable, simple to use programs called CADS Hub. Maybe worth a look on our website. They cover things from timber to steel to concrete and glass and so on. And in there are a couple of concrete solutions, TR34 for ground bearing slabs and a punching shear program. So these are standalone, again, individual programs. If you really want to go into 3D and projects these days, they vary in size and scale, then really at the top end we've hooked up with the German company Dubal. So we use RFEM for helping people to do some of the more complicated structures. I mean, indeed, this is a very simple looking geometry compared to some of the projects I've seen. They're far more organic, and indeed you can do flat slabs and columns and beams and all sorts, all in one model, all linking through. But again, if you're looking at finite elements and you've got irregular slabs with horrible loads on, just get a 2D solution, put your columns in as supports and loads on that, and we can offer you a solution for pile rafts and indeed separate 2D slabs, flat slabs. Okay, thank you very much for your attention, for your time today to listen to the video. If there are any questions which you would like to contact us about, there's a phone number there and an email. Be very happy to get back to you. And alternatively, have a look on the website and see if there's any more information, and keep an eye on YouTube. We're doing a lot of videos and maybe you'll find another one that might interest you. Thank you very much for now. Bye bye.